I hope you guys are happy. And today's notes, area of a triangle. Before we start doing law of sines, that's where we're going to derive law of sines from area of a triangle, but you'll see. You guys already have experience with area of a triangle. It's 1/2 base times the height. Usually you have right triangles, so it's easy to figure out the height because it's perpendicular to the base. So I'm just going to draw a generic triangle, guys. I'm going to draw something with the base being horizontal like this. And I'm going to just try not to draw a right triangle. Just going to go and then, I don't know, maybe it looks like it's a right triangle right there, but it's not. I tried to just draw just something generic. I'm going to call that point A. I'm going to call this point B, or vertex A, vertex B, and vertex C. Angle A, opposite of angle A is little a, opposite of angle B is little b, and opposite of angle C is little c. Nothing crazy. Area of a triangle is always going to be 1/2 base times height. Sometimes some textbooks will have a base times height divided by 2. It just depends how you learned it. The height that they're talking about is the perpendicular height to the base. So they're talking about this distance. That is your height. It has to be perpendicular to the base. So perpendicular to one of the sides. We're still okay? All right. If we focus, and let me highlight it. Do you guys see this triangle right there? That right triangle? So if we do, and Oyani, that's a demerit. If we were to do SOHCAHTOA, and let me highlight this so I can link it. So I'm highlighting SOHCAHTOA because I'm linking it to that triangle right there specifically. If I were to do SOHCAHTOA on that specific triangle that I highlighted, I would say, well, specifically just sine and cosine of that. So sine of that angle A, so I'm going to put A for angle A, is equal to opposite over hypotenuse. So I would say H over C. Oh yeah, because we're doing area of a triangle. We don't care about cosine, so it doesn't matter. I'll probably delete this from my video. It doesn't. No, it's correct. You don't have to exit out, guys. It's correct. If I call that X, adjacent X over H, but we don't need it in this case. All right. So you see how I have this formula here that sine is H over C? If I multiply this sucker by C, whatever you do to one side, I do to the other, right? I'm sorry, I shouldn't have called it a sucker, but if I multiply that, so I have H equals C sine A. We're still okay? If I substitute this for H right there, I'm gonna get this. So let me substitute area equals 1/2 base, open parenthesis, and I'm gonna write C sine A. If I drop the parentheses, I get this. Area of this triangle is 1/2 BC sine A. And there it is. That's how I find the area of any triangle, regardless if it's a right triangle, as long as you're giving the angle, this angle, and then the sides that connect to that angle. See? If I wanted to find, so let's just do it for kicks, another one. Let's say I wanted to find, let me change my highlight color. Do you guys like pink? Okay. If I wanted to find this one, oh, I heard a no. Do you guys see that right triangle there in pink? So if I were to do SOHCAHTOA with the one in pink, and I'll highlight that section already in advance here, and I were to do angle C here, and I were to do sine of C, so look, sine of C equals opposite H over hypotenuse, which is A, and I were to solve for H again, so I'm going to go times A, so then I get something like this. Let me go back to blue. I get H equals A sine C. And if I were to replace that with this H again, starting at this one, then I will get area equals 1/2 B, open parenthesis, A sine C. And if I drop the parenthesis and put it in alphabetical order, A going first before B, right? Because in the alphabet, A comes before B in the alphabet. A, B, sine C. And that is also the area of that triangle. It's the same. It gives you the same answer. So using context clues, I have one more. So let's see. I have 1/2 BC sine A. Notice that's angle A, and I have B and C. I have AB sine C. That's angle C. So notice that's A and B. So there's one more answer. There's one more area of this triangle. 1/2. Let's see. What letters have we not used? Okay, a little. Angle B, big B. So that means that I'm gonna have A and C sine of B. All three of these, and then we'll derive the law of sines later on with those three. But all three of those give you area of this triangle. How are we feeling? Nothing crazy, right? Okay. Now all we're gonna do is just use this. Cool? Yes. So flip the page. And all the calculators, unless you reset it, all the calculators should be in degree mode because when I placed them in your desk, I put it in degree mode for you. But just in case you don't know, you're welcome. Just in case you don't know how to put it in degree mode, just push mode and, well, look, my calculator's not in degree mode, so let me put degree and degree. If you have the colored calculator, it'll say degree. If you have the old school calculators, it won't have this border up here, so you got to check it to see if it's in degree mode or not. All right, I'm going to draw a triangle. I'm going to put not to scale because none of my triangles are to scale. And it says in triangle ABC, so I'm just going to draw ABC. You don't have to be perfect, guys. A, B, C. So little angle A creates little a, so this is little a. This is 13 inches. Angle B creates little b, so this is 15 inches. And angle C creates, angle C creates little c, but I don't have little c. And that is 71 degrees. So I'll put 71 degrees right there. It says find the area of the triangle. So you guys ready? We're going to go slow. To find the area of the triangle, I'm using this formulas. So notice, if I use angle A, I better have side B and C, which, by the way, B and C meet at angle A. See? B and C. So it's the same thing with this. If I'm going to figure out what the area of this triangle is using angle C, I better have little a and little b, which meet right at that vertex C. Hey, relax, we're good. Do you guys see that? So area, and I like to put subscript T for triangle, but you don't have to. Area of this triangle is 1/2 13 times 15. All I'm doing is my formula, AB sine C. Sine of 71 degrees. Yeah, sine of C. And you're done. In the industry, you'll hear the term plug and chug. Did I already talk to you guys about that? Okay. Yeah, so you're just plugging and chugging now. 0.5 for half, unless you want to push half. It's not a big deal. Times 13 times 15. Yeah. Times 13 times 15. And then I push sine of what? 71. And then bam. And that's it. 92.188. 92.188. And this is area. What are my units on this one? Well, square inches. And I know I put chop, that's inches squared. But when you're talking about area, you say square inches. Chop, why? That's you, supposedly, right? So, yeah, why? Okay, look at the floor. Look at those tiles. I'm looking at some tiles here by my floor. I'm looking at 1, 2, 3, 4. I don't know. You can look at as many tiles as you want. Do you say, wow, those are 4 tiles squared? Or do you say, well, those are 4 square tiles? 4 square tiles. Area is this is a 2-dimensional thing, so it's in units of squares. So when you're talking about area, whatever the units are is whatever those units, you say square and then those units. If they're meters, square meters. If they're inches, square inches. If they're centimeters, square centimeters. Does that make sense? So if you ever hear a science teacher or a math teacher say inches squared, be like, for units of area, you should say square inches. But, okay. Anyways, but be nice. Don't be like mean to them, because everyone makes. I'll stop because then we'll do that trend, right? Everyone makes mistakes. All right. Let's go to the next question, guys. That's it. That's not gonna get harder than that, pretty much. Look at this one. No, relax. We're not clear completely yet. It says find the area of triangle JDH. So not to scale again. Not to scale. And I'm just going to draw up some random triangle. JDH. Angle J creates little j. This is 5, so little j, 5 centimeters. Angle D creates little d, so this is little d, 7 centimeters. And angle H creates little h, this is little h, and that's 11 centimeters. We're still okay? It says find the area. Okay, well right now, the only way I can find the area with what we just did is I need an angle. I don't have an angle. I just have 3 sides. But on what day was it? 2 days ago? Wednesday? But on Wednesday, you guys learned a rule that was called law of what? And with law of cosines, as long as we're giving 2 sides that connect to one of those vertices, we can find any angle. Look, we got 3 sides. We can find whatever angle we want. We can find angle J, we can find angle D, we can find angle H. We just need one. What angle do you guys as a class want to solve for? Doesn't matter to me. Angle D? Okay. If I'm going to find angle D, then I'm going to put little d on the outside of my equation for law of cosines. So I'm going to go 7 squared equals, hopefully you've done law of cosines enough that you already memorized the formula. Don't worry, I will let you use a note card for the exam. 5 squared plus 11 squared minus, do you guys remember? 2 times cosine of angle D. So we're going to find the angle D. What you're doing now is algebra. So you can see why algebra is important. So I'm trying to isolate cosine D here. So 7 squared is 49. So I'm just expanding it. 5 squared is 25. And 11 squared, what's that? 121. And then 2 times 5 times 11. 2 times 5 is 10. And then 10 times 11, what's that? 110. Okay, 110. Cosine of angle D. Are we still okay? All right, here we go. 121 plus 25. 21, 31, 41. Yeah. 49 equals 146 minus 110 cosine of D. Are we still okay, guys? Okay. I'm going to move the 146 to the left. Minus 146, minus 146. So 49 minus 146. Negative 97 equals negative 110 cosine of D. So catch up to here. How do I get angle D, or how do I get cosine D by itself? There you go. So I'm going to write cosine D equals negative 97 technically divided by negative 110. What's negative divided by negative? So I'm going to leave it as 97 over 110. Is that okay with you guys? Yeah. Okay. Last move before I get the angle. How do I get the angle? Arc cosine it. You can also say what? Inverse cosine. Both are the same. Arc cosine or inverse cosine. D equals cosine to the negative 1, open parenthesis, 97 over 110, close it. And I'm going to take my calculator, and I'm going to go arc cosine, and I'm going to go 97 divided by 110. You don't have to do the fraction thing unless you really want to, because you can it's just one number there. And then push enter, and 28.1375. That's what I got. The more digits you can write, the better. It's a degree, so put a degree symbol. 28 point, and I already forgot it, short-term memory. 1375. 137. I wrote 5 instead of 7. 75 degrees. Okay. Now, because I'm going to store this angle. You don't have to, guys, but I want you guys to, you're going to see something super amazing in a little bit. I'm going to store this in the calculator. And the way I'm going to do it, to store every digit per digit, I'm going to push this button here and see how it says answer. And I'm going to go alpha, and I'm going to choose D because it is angle D, and I'm going to push enter. The D is right where it says matrix. I guess on the left-hand side underneath the math button. Cool. All right, here we go. Now that I know angle D, I can find the area of this. So here it is. Area equals 1/2. And then if I'm using angle D, I need the 11 and the 5. So 1/2, 11 times 5. And then what is it? Sine of angle D. So here I go. I take my calculator. 0.5, 11. Was it 5? I already forgot. 5, and then sine, and I'm going to put alpha D. I guess I could have scrolled up too as well, but bam. 12.9687. That's the area. 12.9687. What are my units? Square centimeters. Good job. Look at you guys being nerds. How do we feel? Okay. You're about to be mind blown. Well, I don't know. I'm always mind blown. I'm always so shocked. There's always so many things that shock me. What year are we? So 100 BC was 2,300 years ago. This guy, sometimes if you Google his name, sometimes it's spelled Heron instead of hero. So I don't know. It just depends what textbook. I'm not a history buff. Maybe I talk to someone who's a history buff. Hero of Alexandria in 100 BC, 2,300 years ago, or a little more, right? A little more, a little less, whatever. You know, we're in 2026. Created this formula to figure out the area of any triangle. And he did this without the technology that we have right now. Let's see how good his formula is. Let's see what it says here. Hero of Alexandria in 100 BC. Hero's formula is this, where S is the semi-perimeter. That's just a fancy word for half the perimeter. So here's how you get the S. And it says, find the area of triangle JDH in example 2 using Hero's formula. Confirm that you get the same answer as in example 2. So here's my example 2. So I'm going to draw the same triangle again. So here's that same triangle. And what did I write? J, D, and H. J, D, and H. Not to scale, like always. And this is 11, this is 5, and this is 7. All right, the first thing I'm going to do, I'm going to calculate my S. Yeah, what the heck? I guess I got to push it again. Bless you. All right, here we go. Calculate my S. 1/2, parenthesis, 11 plus 5 plus 7, close. I take my calculator. I'm going to go 0.5, open parenthesis, 11 plus 5 plus 7, close it, and bam, there it is, 11.5. I guess I didn't even need it, but no, it's fine. 11.5. Okay, now up here it says that the area is, I take that 11.5, so that's my S, so I'm going to go area equals, I'm going to write square root of 11.5, open parenthesis, and I'm just going to follow down, I'm just following that rule right here. 11.5 minus 11, close parenthesis, open parenthesis, 11.5 minus 5, close parenthesis, open parenthesis, 11.5 minus 7, close parenthesis. I'm going to type that in exactly like that into my calculator. And heck, we'll do even one better in a little bit. Let me close this window here. All right. Let me delete this because I want to see if it's a perfect. So here's my answer. So I better get this answer, digit per digit. So I'm going to go square root, 11.5, open, 11.5 minus what? I already forgot. 11, and then times 11.5 minus 5, close, open, 11.5 minus 7. And look at that. Aren't you impressed on how amazing this is? Guys, he did this in 100 BC. Look, it's digit per digit, the same as the answer that we just got a little while ago. You don't think that's amazing? So here's the challenge to you. And I'm not saying because okay. I don't know if, I'll just say it like this because I'm not trying to be mean. Guys, I don't know if I can create something that 2,000 years from now people will know my name. Do you think you can create something that 2,000 years from now people will still be using your work? Because Hero of Alexandria did it. Look, we're still talking about it to this day. You don't think that's amazing? So see if you guys can do something that influences the world that much that 2,000 years from now, they will be talking about your contributions to this world. I just think this is just so amazing, I think. All right. Sorry, guys. I thought that was amazing. Okay. All right. How are your problems going to look? They're going to look like this. This is what you're doing today. It's a Delta assignment. I think I have it due today, but because we're going to have an hour of class, you know? No, yeah, you'll have time, guys. All right. Here we go. It's just application problems. Relax, relax. We're fine. We're good, guys. Let's be happy. All right. The area of a triangle is 12. Okay. Two of the side lengths are 4 and 9.6, and the included angle is acute. Oh, okay. So they're talking about that angle that. Okay. Find the measure of the included angle to the nearest tenth of a degree. Okay. Not to scale. Here's my triangle. Hey, no, Yanni, that's a demerit. And they're telling me this is 4. They're telling me this is 9.6, and the included angle is acute. So they're talking about this angle right there. I got everything I need to solve for that angle. They wanted the angle to the nearest degree. What's the area of this triangle? So I'm gonna write my formula first. Area of a triangle is 1/2 AB sine C. And I guess I can write a C here like that. So this is like your A, this is like your B. You need those two angles that or those two side lengths that hit up this angle. All right, so here we go. 1/2 parenthesis 4 times 9.6, and then I'm going to write sine. And I guess I could write sine of C, but I put a theta there, so I'm going to write theta. Are we okay? Okay, here we go. I'll take my calc. Oh, by the way, what's the area of this triangle, by the way? So I'm going to put 12 right there. And you're done. All you're doing is solving for theta, so it becomes algebra. So I'm going to go 1/2 times 4 times 9.6. What's that, like 20 or something? 0.5 times 4 times 9.6. I was close. 0.5 times 4 times 9.6. 0.5 times 4 times 9.6. Yeah, there we go. 19.2. So I'm going to write 12 equals 19.2 sine of that angle. How do I get sine theta by itself? 12 divided by 19.2. Yeah, I put the 2 way out there, right? Equals sine theta. All right, how do I get theta by itself? Arc sine. So I'm going to write arc sine of 12 divided by 19.2 equals theta. I take my calculator and I go arc sine of 12 divided by 19.2. Bam. 38.682. The more digits, the better. Oh, wait. Well, I guess I'll write. This is not the more digits, the better, because they gave me explicit instructions. 38.682. All right. They said to the nearest what? Nearest tenth. So that means 1 decimal, 1 point after the decimal. So 38.7. 38.7 degrees. And I'm going to circle that because that's what they wanted. How do we feel? Okay. Let's go to example 5. Don't worry, we got 2 left. We shouldn't take too long. The area of a parallelogram. Ooh, do you guys know what a parallelogram is? Okay. The area of the parallelogram is 13, and the length of the sides are 9.4 and 1.7. Determine the nearest tenth of a degree, the measure of the acute angle of the parallelogram. Okay, so here it is. Let's draw a parallelogram. So do like a slant there, and then slant, and then bam. So this is 9.4, 9.4, 1.7, 1.7. You could, if you wanted, take that 13 and divide it by 2. Like if you see this triangle right here. Let me draw a diagonal. But I like to work with the 13. So let me, Chop, what are you talking about? So area of a triangle is 1/2 AB sine C. But I see 2 triangles there. Do you guys see how you have 2 triangles there? So I like to take this formula and multiply it by 2. So I'm going to put area and I'll put P for parallelogram. If I take that half and I multiply by 2, there it is. See? So that's the formula you're going to be using to find the area of a parallelogram. Does that make sense? Okay. So they want me to find this angle right here. Because they said acute, the other one's obtuse. And Oyani, this is the merit. All right, so here we go. I have the 1.7, I have the 9.4. Perfect. That's what I need. I need the 2 segments that connect at at that vertice that create that angle there. So I'm going to go 13, because that's the area of the parallelogram, equals 1.7. So that's a parenthesis for 1.7 times 9.4 sine of that angle. There it is. You're done. Now you're just doing algebra, arithmetic. So I'm going to go 1.7 times 9.4. So 1.7 times 9.4. I got 15.98. So 13 equals 15.98 sine theta. What's my next move? Divide. So I'm going to write 13 divide. I'll write it over here. 13 divided by 15.98 equals sine theta. What's my last move? Inverse sine or arc sine. Perfect. Inverse sine of 13 divided by 15.98. And that's going to give me my theta. So theta equals, and let's see what that is. Arc sine of, I already forgot, was it 13? Yeah. Divided by 15.98. 15.98. 54.441. Oh, well, did they say nearest degree? Nearest tenth of a degree. 54.441, and I'll change it right now. So my answer is 54.4. There it is. Cool or not cool? Okay, one last one. Here's our last one, and then we'll set you guys loose. So you'll have an hour. The area of a parallelogram is 21, so we're still dealing with parallelograms. And the length of its sides are 8.6 and 3.1. Determine to the nearest tenth of a degree the measure of the obtuse, underline the word obtuse, angle of the parallelogram. All right. Properties of a parallelogram. Anytime, okay, I'll just start. Guys, every time we do inverse of anything for this situation, since sine in quadrant 1 of the unit circle from 0 to 90 degrees, you hit all the positive values, right? Like 0, remember, sine of 0 is 0, sine of 90 is 1. So what I'm trying to say is, every time we do the inverse sine of some ratio, you're always going to get an acute angle. But we know, here's theta 1, and I'm going to call this theta 2. We know that theta 1 plus theta 2 in a parallelogram add up to, do you guys remember? No? 180. Theta 1 plus theta 2 in a parallelogram add up to 180. These theta 1s. These thetas. Theta 1 and theta 2. Cool or not cool? And if I were to write theta 3, theta 4, then theta 1 is equal to theta 3, and then, okay. Anyways, does that make sense to you guys? All right, so when I write 8.6 right here and 3.1, and then 3.1 and 8.6, the calculator is dumb. It's not going to give me theta 2. It's not going to give me an obtuse angle. It's going to give me an acute. So we're going to have to subtract from 180 whatever angle we get to get the angle that we want. Does that make sense? All right, so here we go. I'm going to write, what's the area of this parallelogram? So I'm going to write 21. There we go. 21 equals, and then I'm going to write 3.1 times 8.6 sine, and it's going to give me the theta 1. It's not going to give me theta 2. But I want theta 2 because they told me obtuse. Does that make sense, guys? All right. So again, I'm going to go 3.1 times 8.6. And don't worry, we'll test it out to make sure that everything is legit. 3.1 times 8.6. And we get 26.66. So we have 21 equals 26.66 sine theta 1. Are we still okay? Okay, what's my next move? Divide. So I'm going to write sine theta 1 equals 21 divided by 26.66. How do I get theta 1 by itself? Arc. Inverse sine of 21 divided by 26.66. All right, I take my calculator. I'm going to go inverse sine of 21 divided by 26.66. Close. Enter. There it is. That's an acute angle. I'm going to store that to A because I'm going to test it in a little bit. So 51.971. 51.971 degrees. But is that what they wanted? No. So how do I get theta 2? Subtract from 180. So theta 2 equals 180 minus the 51.971. So let's see what that is. So 180 minus, I have it as A here, so I'm just going to say A. I'm going to store that to be 128.029. And that's my answer. 128.029 degrees. Bam. Okay, you guys want to see something cool? It doesn't matter if I use theta 1 or theta 2 in this formula. In this formula here, I will get 21. Watch. Chav, what are you talking about? So look, because remember, that should be my, okay, watch. 3.1, because, yeah, I know, because I was in mid-thought. Let me just tell you what I was going to say. See this 8.6 and that 3.1, and they converge at this vertex here, and I can use that angle. But look, this is 8.6 and this is 3.1, and they also converge at this point here, and I can use that angle. So I can use either one, and I'll still get the 21. So 3.1, watch, 3.1 times 8.6 sine, and let's try the 51.97. I have that as A, so sine A. And why did I save it? So you'll see that it's the same digit per digit. Enter. Look, 21. If I scroll up, that's not a surprise. Obviously, you're like, yeah, what about if you use the other angle? Well, I saved the other angle as B, the 128.0291. Look, alpha B, if I put a B, look, there's a B there. Oh, look, it's the same answer. Isn't that cool? So it doesn't matter how you, as long as you understand how to apply the formula, it doesn't matter which one you use, you're always going to be correct. Now, remember, guys, we derived the formula from scratch, so it didn't just magically appear. Do we understand? Like, okay, like, are we good with that, guys?
Yeah.
All right. Oh, we're not good? Who's that? Oh, yeah, we are. Okay. All right, that's it. So just take care of Delta, and I hope you're satisfied with your education, guys. All right. See you guys later. Oh.